Hi there, my name's Mark Payne. I'm an audio engineer here at SFL Group in the UK, and I wanted to share with you this product, which is the UNiKA Dante I/O box. It's a 16 channel I/O box, but it can be expanded as a pair to 32 channel. Of course, you can expand these things indefinitely because we can just keep on adding more and more units to the Dante network. But let me take you through what this product is. This is an NBB 1616. It's a 16 input, 16 output Dante enabled I/O box. You'll see some of the connectivity around the back shortly, but first I just wanted to show you the front of the unit, which is 16 individual mic preamplifiers. Now these mic pre's are based on the VAT Corporation 1580. They're superb mic pre's, and later on I'm going to be showing you examples and demonstrations between the quality of this mic pre and going into other consoles directly. So the purpose of this box, you could use it as a standalone multi-core replacement system. If you've got an analog multi-core, you could have two of these boxes at one end of the stage, two at the other end, and you would end up with 32 channels bi-directional. Let me just show you the rear of the box, and that'll become more clear. So what we have here there's an I/O card which has got 16 inputs, and then there's an I/O card that has 16 outputs, and this unit is always configured in this way. The one working at the other end of the stage would be absolutely identical. There's not a front of house and a stage box. They're both bi-directional, and so effectively you would connect two of these together and you'd have 16 channels going one way and 16 channels coming back. You can see that the unit is Dante enabled. There's a primary and a secondary Dante, so it supports redundant networking. Also, these are implemented as a switch. So there's a configuration of the box where instead of being primary and secondary, they just basically become a two-port switch. And that enables us to realize cascaded networks where we come from one I/O box and then onto the other I/O box, which reduces the amount of switch equipment that you will need to realize the I/O system. The NBB 16 concept is the 16 channels of break-in and 16 channels of breakout, breaking it into the Dante network. However, using the same Dante chipset here, this is the 32 channel version of the chipset, so you've got 32 ins and 32 outs. Of course, you can't see 32 ins and 32 outs here, but that becomes available to you via the expansion port. So there is another version of this. In fact, I've got one here, so let me just get it. This looks identical, but in fact just slightly different. You'll notice that there's no Dante ports on this unit. It's an expansion unit, and effectively what we do is simply plug in the interconnects, which are digital interconnects. Obviously, as soon as the signals hit the input, it's become digital. And now what you have here is effectively channels 1 through 16 of input and 17 through 32 of input. So it's basically become a 32 channel unit with 32 outputs. Of course, you would have the same thing at the other end of the stage. Maybe this is at front of house and you've got the same thing going on somewhere else. So you can use this as a 32 bi-directional, and now you're using all the Dante resources that have been provided on the box. So that's the expansion unit, which I'll just remove. Okay, so all well and good. There's a couple of useful buttons that are provided. One is it's really simple to set this up as a peer-to-peer unit, so this and its friend down at the other end. You don't even need to patch the thing with Dante Controller. I'll be showing you Dante Controller later, but it's very easy. You just set the two units up, press the button, and they self-address and self-patch each other. What happens is 1 to 16 of the inputs here get patched to the outputs at the other end, and vice versa. 1 to 16 of the inputs at that end get patched to the outputs here. You do that, it's all self-addressing, and it happens. You could even connect the units directly, primary to primary, secondary to secondary, and you wouldn't need a switch in the way because you've just got one unit connected to the other unit. You could even do it just using a single cable if you didn't feel the need for the redundancy. So that's the peer-to-peer pairing. This is changing the mode. It says either redundant or daisy chain. It's basically changing the switch mode of the Dante configuration to be 2 ports of a switch or individual primary and secondary networks. If you're not using the redundant feature. Then we have the ability on the 3rd dip switch to turn the meters off in the front if you want it to be running in dark mode. And then there's the 4th dip switch doesn't get used. So they're the controls that you've got on the back. In more complex Dante networks, we'll be using Dante controller to configure multiple boxes like this, so we can route any input to any output. But we have got the peer-to-peer pairing system if you want to make it a simple one-to-one relationship. Coming back to the front of the unit, you can see that we've got basically each microphone has got its own gain control, and the gain control is in 12 dB steps. We start at 0 dB, plus 12, plus 24, and so on, all the way to 60 dB. So there's enough gain control there to look after pretty much gain matching for any microphone that you're ever going to want to use. We get metering in 10 dB steps. We're starting at minus 60 dB on the metering, so that we got minus 60, minus 40, minus 20, minus 10. So it's a 20 dB jump for the first one and then 10 there on in. It's important to realise with digital networking that we don't need to overdrive inputs here. The noise floor of these systems are so low. You have to remember here that you're dealing with 24-bit quality audio. Now, when we talk about CD quality, we often talk about a thing having CD quality. You have to remember that's 16-bit audio. And effectively, every time we add another bit to the bit depth of the signal that we're dealing with, we're adding another 6 dB of headroom and doubling the resolution. So my advice would be, with all of these 24-bit systems, which most digital consoles and I/O boxes like this in the modern era are 24-bit, it's really important that you don't try and use up all of the bit depth for your signal. It's not necessarily to do that. This is not like a metal tape back in the day. So as far as I'm concerned, if you are reaching the 3rd ppm up, which is at minus 20 dB, you're preserving 20 dB of headroom. Okay, so what I've done now is I've plugged just a switch microphone, a dynamic microphone into channel 1. You can clearly see here channel 1. If in my loudest passage, you know, that would be way too loud. I need to click some gain off of this. And what I'm recommending therefore, even if I get excited on the microphone, then I'm hitting the minus 20 dB point, and that would be an appropriate gain structure setting for a digital input box. It doesn't really matter whose input box this is. You can clearly see that even if I get excited, I'm not going to get any louder than the minus 20 dB, making sure that I've got 20 dB of gain structure. And effectively, if I look at the control that I've used here, I can feel it's 1-2 clicks up. So I've added effectively 24 dB of gain to the mic pre. Now let's just review what the other buttons are here. Well, first of all, we've got a 48-volt phantom power for a microphone that needs that, for a condenser mic or a capacitor mic. I've also got a minus 18 dB pad and also a polarity, a 180 degree phase. You might call that a phase shift or a polarity shift. They're the additional controls that are on the unit. Now, also, this metering is metering when this button is in. The meters are metering input levels, but if I release the button out, and then the meters are metering what's going out on the outputs. It's output bus metering, not input metering. Right. You can see that we've got status LEDs here, and at the moment you can see that our network status is we are connected at 1 gigabit. On the Dante, and also that the sampling rate of the unit is set to 44.1 or 48. You can also see we have available 96K and also 192K sampling. So that's the NBB 1616, the break-in, break-out I/O box, Dante enabled.